Hello, Honor 7. So I wanted to go back over with you a new unit, which is on reflections. Okay. I'm going to be using my cell phone. That does not mean your cell phone should be out necessarily in class if you are a face-to-face student. We're going to talk about reflections, which have an interesting history in the United States of America. So I'm on page 135, and then we're going to wrap up reflections on Wednesday. So we're going to work through our lesson, and then we're going to take some notes on that packet that I sent from last week. And then we're going to practice some more on Tuesday, because remember, we're off of school on Monday. So it says the astronauts aboard the Apollo moon missions in 1969 through the 1970s did more than just play golf and take pictures. They also set up equipment on the moon to help scientists measure the distance from the moon to the Earth. The equipment contained a set of mirrors called retroreflectors, kind of like the same material that's on your phone that'll help reflect. Scientists on Earth can now shoot laser beams at these mirrors and calculate the distance to the moon by observing how long it takes the laser beam to bounce back. Really, really interesting. In fact, my dad told me that PBS has some fascinating things on math and science when they went back to the Apollo moon mission, and all the kind of mathematics and science engineering that went through all the data they collected there. So we're kind of going to have a mini mirror lesson today. So it says, in this lesson, you'll explore what happens to geometric figures when they are reflected across different lines. Look at the triangles shown in the coordinate plane. A, describe the position of the two triangles on the coordinate plane. Do you think they're congruent? Remember, congruent means same size and same shape. B, place a mirror on the y-axis facing to the left. Now, I'm going to say for mirror, use your phone, or you can even take a look, put it on your Chromebook and see what you're noticing about it. To the right and to the left, you can kind of take a look and say, aha, interesting, pretty neat, right? Describe what you see looking at the triangle in the mirror both ways. Okay, and then when you're ready, when you've answered those three questions, press play. We're going to take a look at it. All right, so by continuing to press play, you've promised, you've looked at that, noticed some cool things. Now it says, look at those two triangles. What do you notice? Are they congruent? Yes, they are the same size and the same shape. Place the mirror on the y-axis facing to the left. This is my left. Whoa. So you can kind of see that this is the same distance and direction as the other one. In fact, it looks congruent. Okay. Then I'm going to go like this way. Haha, look at that. Same distance and direction as the other, right? So I'm going to put it's the same triangle. I want to use the word flipped to describe reflections. Excuse me. So it says, recall that figures that are mirror images of each other are what we call reflections. A reflection is a transformation that flips a figure across a reflection line. A reflection line is a line that acts like a mirror. In this coordinate plane, either triangle is a reflection of the other. What do you think the reflection line is shown? Okay, so I'm going to go back to the patty paper. This is my wax paper. You don't necessarily need this today because you've got access to a phone, either your parent or yours. But I just wanted to show you something that's pretty neat. So I'm going to come over. Let's say I wanted to reflect this across my y-axis, which we're about to talk about. I could just flip it upside down across my y, and there's my y reflection. Okay, it's kind of what tracing paper can help. Your paper is also thin enough that you could tear that out and use that too as a resource. So where could I actually fold this? And that's why this paper is a little powerful. I could fold it over, and I could see that it would be right there overlapping on my y-axis. That's what lines of reflection are. Where could you fold that shape over that would reflect it so it's exactly congruent, same size and same shape on top of the other one. So hopefully you saw this is your y-axis. Okay? And then I love what your book does next. Now it says, instead of going side to side, draw a reflection across your x-axis down. Okay? Excuse me, draw a reflection across your x-axis down. Now to do that, you could use your phone, or this is your x-axis. You could literally count. This is 1, 2, 3, 4 to my x, so I have to count down that many. And I'm going to count down 1, 2, 3, 4. the other way. And then I put my point, okay? So you're going to go down for E. Then number 2 says, reflect the parallelogram ABCD using the y-axis of reflection to form parallelogram A prime, B prime, C prime, D prime. So instead of counting to the X line, now they're having us count to the, you see that? Y line. So I have to come over and say this is 1, 2, 3, 4 blocks. So I have to count to the right. 1, 2, 3, 4. The same distance and direction, right? Not too terribly bad. And then 2B says, describe what you're noticing for the relationship between the y-axis. Now I'm going to say on B, go ahead and list out your starting coordinates so you can see what's happening. Excuse me. And then go ahead and list out your B coordinates. What are you noticing for those two? All right, so go ahead and pause the video. And when you're ready, press play. All right, so let's take a look at what our X reflections look like. All right, so you can see that these triangles are congruent. And I just went real quick and knew that that was 4 to X, so this is 4. That this was 8 to the X line, so I go 8 to the other. So you can see that these kind of flip top to bottom. Same thing here. I know this is 4 blocks up. That's 4 blocks up. So you can kind of take a look at what we're doing and saying, I notice that X stays the same when I'm reflecting across X. But what happens to your Y values? They go from being positive to being negative, right? Really interesting. So I always find it interesting that when you're reflecting across X, it kind of folds top to bottom. Really interesting. All right, let's look at Y. So Y is going to be a nice, pretty little shape, and then I'm just going to put that they are all congruent, making sure everybody can see that. That's okay. And then I can come over and say A, it goes from being, let's write our original coordinate from A, -4, +1, to becoming +4, +1. What stayed the same when I'm reflecting across my y-axis? I'm going to write that so you can kind of see what we're doing. If I reflect across y, y stays the same. If I reflect across x, my x coordinate stays the same. All right, let's keep going. We said our original B coordinate was -2, 2, and then that became +2, 2. Same rule. Let's look and see. That's 1, 2, 3, 4 to that axis. So that's -2, -3. So my new thing would be 2, 3. 2, -3. And then I always show, to show that prime notation, to show that's what our original shape was going to look like. I know D goes from being -4, -4 to being 4, -4. Excuse me. My allergies are not being nice today. 4, -4. All right, and you can see, once again, the y coordinate stays the same. The x coordinate flips its sign. Whoa, sorry about that. The y coordinate flips its sign. All right, now we're going to kind of ramp this up a little bit. Hopefully you see that your pre-image, your starting shape, is congruent to the shape once you've transformed it. Okay, so I love reflections. It's just like flipping the shape side to side for y, or flipping the shape top to bottom for x. All right, and then it said, what did you notice? We kind of talked about that y stays the same, x coordinate flips its sign. Okay, now we're going to look at something that's a fun honors challenge. Okay, so I'm going to jump to 3 on the next page, on page 138. Now we're going to practice reflecting this across our x-axis to see what the rule is doing. Okay, so I'm going to come over and put my original coordinates. And I know that A is -4, negative 1. I know that B is 1, positive 4. I know that C is 2, 2. And I know that D is negative 3, negative 3. Okay? Now we're going to talk about reflecting this across X. Excuse me. So I'm going to start with A and D. Now I have to count up to X. That's where X is. So A is 1, 2 to X. So I have to count 1, 2 up. What is that new coordinate? That is negative 4, positive 1. Ooh, look what happens when we reflect across X. Do you see that? Remember, X goes before Y. X stays the same. Your Y sign flips. Let's look at D. That goes from being negative 3 to being 6 up. Negative 3, positive 3. What just happened? X stayed the same when you reflected across X. The Y value changed. Now we're going to do the same thing for B, but instead of counting up, because this is above my X, I have to count down. So 1, 2, 3, 4, 5, 6, 7, 8 to X. So I have to go 8 to the other direction. So that's going to be my new B. Count 8 down. So my B value goes from being 1, negative 4. So you can see once again, X stays the same. My Y sign changes. The same thing for C. That's 4 above X. So I have to count 1, 2, 3, 4 below. And it goes from being 2, positive 2 to being 2, negative 2. And this is going to be my X reflection, right? So what did we notice if we reflect across our X axis? Whoops. X stays the same. Our Y coordinate changes. And so that's kind of what the rule looks like. X coordinate stays the same. My Y coordinate flips its sign. Okay, now I needed you to get out the notes page. Just bring all this together in notes form. Looks like this. I emailed it out if you're a remote student last week. Okay. Oh, wait, hold on. Let's jump to 4 before I look at notes. 4 on page 139. It says, if the triangle is reflected across X, what would the ordered pairs of the vertices be? So X means that first coordinate stays the same. So see if you can write what your new coordinate's going to be. Okay. Then we'll talk about what the Y reflection looks like. So go ahead and pause the video. And then when you're ready to go with the X and Y axis, press play. All right, so I know if I'm reflecting across X, I just learned that X stayed the same, but my Y coordinate changed its sign. I know B goes from being 1, 5 to being 1, negative 5. And I know that C, my first value stays the same, but my second value is going to change its sign. So that's 2, 2. Whoops. Now, if I look across at Y-axis, I know that the Y value is going to stay the same, but my X values are going to change. So this is going to become positive 4, but Y stays the same. My new B coordinate is negative 1, but my Y coordinate stays the same. That's 5. And my C coordinate, X flips its sign, but Y stays the same. And that's why I love, love, love the foldable we're going to do. Okay? So the foldable, or your notes, looks like this. And we don't have to worry about 2 of them. You just have to pick one. I'm probably going to go with the bottom one. It says, reflection is a change to a figure by flipping it either across the X or Y axis. No change is made to the size and shape of the figure. So to reflect this across our Y-axis, plot each point the same amount of spaces from the Y-axis in the other direction. The Y coordinates do not change. They stay exactly the same. The X coordinates change to their opposite value. If they're positive, they become negative. If they're negative, they become positive. So that looks like this. Okay, so X flips its sign, so that becomes 7, 6. Y goes from being negative 4, negative 6 to being positive 4, negative 6. This goes from being negative 4, negative 2 to being 4, negative 2. And I know that there's no coordinates because you could also put y and show that this is your y reflection. Excuse me. And I can count over 1, 2, 3, 4 to y and count 1, 2, 3, 4 blocks here. That's my new C value. I can count 1, 2, 3, 4 blocks to y. Count 1, 2, 3, 4 blocks over. And then I know A is going to be 5, 6, 7. So I have to count that distance, 4, 5, 6, 7. So that's 4, negative 2. 7, negative 6. It's going to be the same thing. And you can kind of see, oh, look at that. That's my y reflection. Y reflections go side to side. They're congruent. They don't change the size or shape. All right, let's look at x-axis. It says to reflect a figure across your x. And I actually want you to draw your arrow up and show that this is an x reflection. Plot each point the same amount of spaces from the x-axis in the other direction. The x-coordinates do not change. They stay exactly the same. The y-coordinates change to their opposite value. If they're positive, they become the same number that's negative. If they're negative, they become the same number that's positive. And then once the point has been plotted as a new coordinate, it is then named as prime. This tells you it is the image of the original. So A becomes A prime. So x reflection means x stays the same. The y value flips. Okay? So this goes from being negative 7, it stays that way, from negative 6 to positive 6. Negative 4 to positive 6. Negative 4 to positive 2. And then I have to count up, or I could use what I know about coordinates if you don't see the coordinates to plot it. So this is 1, 2 to x, so I have to go 1, 2 up. This is 1, 2, 3, 4, 5, 6 to x, so I have to go 1, 2, 3, 4, 5, 6 to get my new one. Then this is going to be the same thing, 6 up to my x line. So I have to count 1, 2, 3, 4, 5, 6. I'm going to put 2 dashes to show that. Okay? So x reflection goes top to bottom. Y reflection goes side to side. Reflecting just means that there's no change to the size and shape, but you're just flipping it side to side or top to bottom. Okay? Now I'm going to also put the homework on Google Classroom. I'm torn between whether I want you to do a Delta Math or a reflection Desmos. But go ahead and check Google Classroom to see what homework Ms. Hang and I are going to decide to assign for Friday. Remember, we don't have school Monday, and I will see everybody back in class on Tuesday, October 13th. Really excited to see some of you face-to-face. And if you're remote, I'm still excited to teach you remote. Have a great day. Bye.